Okay, save the best for last. We have Angélica Vázquez-Ortega, who is assistant professor in the School of Earth, Environment, and Society at Bowling Green State University, and her research focuses on soil and water chemistry, geochemistry, biogeochemistry, and geomicrobiology. So please share your perspective.
Thank you. So thank you, Bill, again for inviting me to this event. We all are learning a lot about, wetlands and so on. So my perspective is going to be from a soil scientist, and I'm going to very briefly mention two of the research that I'm doing at BGSU. One is I am working with farmers. I have been collecting soil samples, and I'm looking at specifically how organic matter is involved in the sequestration of nutrients. So my finding so far is that the higher the organic matter in the soil, the higher the sequestration of phosphate and nitrogen. So I think that it's very important. We're talking about nutrients, but also we need to open that black box and see what are the biogeochemical processes that are taking place in soils that are also influencing the retention or absorption of these nutrients. I'm also very interested in understanding how minerals are sequestering nutrients. And some of the farms, they are doing different BMPs, and two of them is no-tilling and cover crops. So I'm wondering if from this wetland culture that Bill is doing, when we do this flipping, if also in addition, to have the, going from wetland to farm, is no-tilling and cover crops can also be incorporated as a BMPs, because I think that those two are going to increase organic matter, and with that, the content of nutrients also is going to be retained in those soils. So I think that we should maybe pair something like that. Another project that I am the recipient from the Lake Erie Protection Fund. I got the grant to use dredge material to amend farmlands in the area. And so what I'm doing is there's a very low likelihood that a farmer will be farming or will be planting in 100% dredge. So the experiment that I'm doing is I'm mixing soil with dredge to see what is the best ratio. And maybe one thing that we can do here is also use a portion of that dredge for constructing wetlands. And I have some knowledge, basic knowledge on the chemical composition of those wetlands, and also I'm going to know if they can be used for farming. So maybe we can use some of that knowledge to how they can be, a good source in wetlands as well. So comments that I would like to emphasize for today's presentation is, again, we need to open that black box, and I'm very interested in understanding all of this research, how organic matter is playing a role in the sequestration or releasing of these nutrients. My research has revealed that phosphate is sequestered into iron oxides, and I was wondering, Lauren, if I know that it's coming to the 10 years, but if by any chance have you looked at redox conditions? Because if we are under anoxic conditions, these iron oxides are going to be dissolved. And I'm wondering if somehow you have been looking at the redox potential. I don't know if that might be the answer in that case. And then the last comment that I have is that Mitch said that if we increase 10% wetlands in the area, we might achieve that 40%. I'm wondering if, when you think about this 10%, are we targeting hotspots? How the distribution of those wetlands, that 10% is going to be distributed, in the Maumee River? Because it might make a difference if we just target a specific areas that has been identified as the hotspots for releasing nutrients into the system. So I just want, welcome this as conversations.
Oh, thank you. And introducing the idea of beneficial reuse, right, of dredge material and others, and the idea of a circular flow, which is how nature managed it. So can we give our distinguished panel a round of applause? What great diverse perspective. Thank you.